So oftentimes, businesses and agencies that we work with have trouble establishing overall visibility to the networks that they currently have in place. And as we know, the network is the transit point for all traffic that extends throughout the enterprise. When we don't have visibility into everything that we have, achieving overall goals like standardization and compliance becomes nearly impossible to do. And exacerbated by this issue, we need environments that are easily manageable when turnover occurs. Top-level controllers and policy engines help us tackle this issue. Now, the policy engine is the core component of infrastructure management and zero trust, making policy decisions for the entire enterprise, regardless of which domain the resources reside in. And as we know, given that everything is implicitly denied in a zero trust architecture, every flow ultimately must be authenticated and authorized before being fully established. But additionally, each domain becomes a large orchestrated sensor gathering metadata and actionable telemetry for event monitoring, for the baselining of the overall environment, as well as consistently analyzing and baselining the traffic patterns and behaviors of users, endpoints, and the overall applications that they consume. So what if we could turn on many of these features with the Cisco infrastructure that we already have in place? What if we could establish the visibility, analytics, and begin the establishment of compliance with the basic incorporation of these top-level controllers? Now this positions us to simply flip that switch with already compatible feature sets existing on the hardware, giving us a pathway to zero trust macro and micro segmentation via programmable fabrics, and a legitimate pathway to establish and expedite our transition to zero trust. Well, welcome back. We're excited to be here. I'm here with Jamie Sambauer and myself, Jeff Fawcett. In this segment, we're going to be talking about the power of programmable fabrics and really how it ushers us into this idea of rapid IT transformation and into zero trust architecture as a whole. Jamie, what are your thoughts on how this works?
Well, I think one of the critical parts here is the multi-domain aspect, which is how do I do this end-to-end and within enterprise architecture itself?
Absolutely. So I think what we're going to do is first we're going to talk about how our networks today or our legacy networks function. And to do this, we're going to be talking three-tier architecture. I'll start drawing and then Jamie can kind of start describing.
Yeah, so one of the kind of critical parts here is it does start with some form of external connection. So most networks actually have some level of external communication with public internet. Now, that's where things start to get interesting, right? We've got some form of perimeter, and that perimeter a lot of times is a WAN edge or an edge router, and some form of firewall or perimeter firewall around it. Now, you definitely picked a nice, pretty color there to show this perimeter firewall.
Yeah, the perimeter firewall oftentimes would segment things like your extranets, your DMZs, et cetera, right? So.
Yeah, and, even down to the level of a lot of people still like to see core firewalling, and that becomes that core central point for policy enforcement. That's actually one of the things that we'll want to dive a little bit deeper into is how do we take that single point and distribute a lot of the policy out in other places.
Absolutely. No, that'll be great. Well, historically, pretty much everything on the trusted side or inside of the perimeter firewall, we've kind of been blind to in a three-tier architecture, right?
Absolutely.
So down here, we'd have basically a backbone or a core. So I'll just say backbone core. And historically, the backbone core is really where all of your major segments come together. Oftentimes, the perimeter firewalls will police security zones, and the backbone core will have, how you distribute down to your node buildings, et cetera. So really, that'll go down to your, like a backbone distribution layer.
And also, sometimes we see this is your MDF closets or some form of main closet, whereas below that feeding some form of IDF or intermediate closet and edge or access switching.
Absolutely. And so I guess this might be a building, for instance, and this might be another building. Let's call this building 100. And oftentimes, I guess, layer 3 would get promoted up to the backbone distribution in this type of situation.
Yeah, and that was one thing that happened about 10, 12 years ago. We saw a lot of people start to make the move between using layer 2 down to the access from the distribution blocks to start to move to layer 3. But all these different challenges kind of arose with that L2 versus layer 3 architecture.
Yep.
And when we say that, it's really about where do you place the IP routing. So in some cases you would have spanning tree and VLANs that would come down to buildings. In some cases it would be IP routing between those two.
Right, and I have always been a big proponent of pushing layer 3 down, mainly to minimize your failure domains, right? To minimize the scope of impact for things like broadcast storms, et cetera. So to that point, let's just say we've got a VLAN, a green VLAN. And that might be some like a green program or whatever, right? And we'll have one here. There we go. And I guess might have a orange VLAN.
Love it. And one of the most important parts is for many, many years we had these different VLANs per use case. So a lot of times we'd see a data VLAN, a voice VLAN. Sometimes they were based on geographic. So building 200 might have a data VLAN and a voice VLAN that's dedicated, and building 100 has something different. The challenge with that is if building 200 and building 100 need to have the same level of communication and policy, it could create some challenges there.
Absolutely. And that's a great point, Jamie. So programmatically speaking, we have agencies across the board that have different programs that are constantly fluctuating and different missions that they want to accomplish. So with that said, let's just pretend that this is the green program and the orange program, but you don't want to intermingle those, right? And so historically speaking, from a segmentation standpoint, we have VLANs down in the buildings, and then upwards, these would all the buildings that were members of, let's say, the green program would have a VRF, right?
Yeah, absolutely. And that actually brought some other challenges too. Just from a VLAN standpoint, I can't tell you how many customers I've worked with over the years that would start to hit some of the maximum limitations for platforms because you can only have a certain number of VLANs, which is typically pretty big, but then spanning tree must run. And when you start to add spanning tree into this topology, it complicates things. Now, some technologies like rapid spanning tree, multiple spanning tree solve some of the problems, but a lot of times it was an engineer or an architect redesigning on the fly to start to deal with some of these new use cases. Many customers ended up running out of space. Like I had too many projects, too many programs, and not enough capacity to be able to meet the need.
Right. And spanning tree was a big operational risk too, right?
Absolutely. Yeah. I don't think you're a great network engineer if you've never lived through at least one spanning tree loop or incident.
Right. Yeah. I'm sure many hopefully haven't, but many have had major campus meltdowns over it. So one of the goals, again, is reducing size of your failure domains. And that's why we've been talking about things like spanning tree, broadcast norms, et cetera.
And as the security guy, I have to say reducing the size of your attack surface. So that was the other big thing here. How do I isolate one project from another just from an attack surface standpoint?
Absolutely.
And don't forget all of the IoT, the printers, the phones, the badge readers. All of that would be maybe a different VLAN that would require some form of policy. A lot of times that policy would be an access control list maybe on the distribution or core, and worst case, we would have to try to trunk things all the way up to some form of firewall, artificially re-engineer the network to make security work.
No, that's a great point. And yeah, we used to have to use VRF light extensions, right, to basically hairpin. So if we wanted to police traffic from the green to the orange program, right? This VLAN would map to VRF. It'd be that network would be a member of the green VRF, but oftentimes, I mean, most of the time, we'd want to police and control the flow of traffic between those. And so to the hairpin point, we'd have to go like this, right? All the way back down. And as you can see, that's a cumbersome process. Not just latency, but in general, it's just bad architectural practice, period. So it's very manual, cumbersome, and what we're going to demonstrate next really will go to show you how to take something like this and turn it into an orchestrated, programmable, enterprise-wide solution that's a lot easier to manage.
Absolutely.
Yeah.